In this goal, you need to determine with a reaction if it is a redox or a non-redox. So not every reaction out there has an electron exchange. There are some that do not exchange electrons, that just as soon as the ions touch, they will react. So there's no going into electron cloud and switching things around and having that electron cloud involved in the bonding. So, or in other words, exchanging electrons in a redox reaction. So let's look at our first reaction right here. So I'm quickly going to assign oxidation numbers because that is a for sure way to figure out if something is non-redox. If the oxidation number doesn't change, then it is not a redox reaction. All right, so once I assign the oxidation numbers, remember, don't put your math in your oxidation numbers. You can look and see if anything has changed from the reactant side to the product side. And if you look, everything is the same. So this right here, this is a precipitation reaction. This is actually a solid that we made right here. And this is a double replacement reaction. And double replacement reactions are never redox. I have initially my two solutions, and as soon as my solutions are poured together and the atoms, or excuse me, the ions touch each other, then they will react and form this solid. So these are never redox. Well, if double replacement reactions are never redox, are there any types of reactions that we can look at and see that they are redox? And the answer is yes. Single replacement reactions always are. So recall, a single replacement reaction is when you take an element and you add it to a compound, and you get a new element and a new compound. So you can see that my A and my B switch places. So this is a single replacement. So this is always a redox reaction, and that's because, remember, when you assign oxidation numbers to elements, they are neutral. And you can see that your element is going to go into a compound, so now it's going to have an oxidation number. Okay, and then this one is going from having an oxidation number to having 0 as my oxidation number. Synthesis and decomposition sometimes are redox reactions. Those you have to assign oxidation numbers and see if anything's changing. Initially, when you look at a reaction, if you see it's a double replacement, you know automatically it is a non-redox reaction. And if you look and you see that you have a single replacement, you know that it will always be a redox reaction. All right, go ahead and stop the video and figure out if these are redox or non-redox. And you can assign oxidation numbers to help you. Okay, we're back now. Let's go ahead and analyze each one of these. So our first one, if we look, we see that we do have an element here on the left-hand side. So that will have an oxidation number of 0. And then over here, I see that it does change. And I will also have another element there that will change. So I won't just gain electrons, I'll also have something that will lose electrons. But to answer the question if this is a redox reaction or a non-redox reaction, I would say yes, this one is redox. On this next one, we see that this one is a single replacement. So I have an element with an oxidation number of 0 going to an element in a compound. So again, this one is a redox. And this last one, this is a synthesis reaction, and I have two elements here that are combining, and so they will have different oxidation numbers on the right-hand side. So yes, these all are redox reactions. So if you're ever hesitant to know if it is or not, just go through and assign an oxidation number. And if you see that the oxidation numbers are changed, you know that it is an oxidation reduction reaction or a redox reaction.